Hi everyone, today we're going to be practicing scientific notation. Just a reminder, anything I write on the screen you should be writing down in your notes, make your page look just like mine. So, scientific notation is a way that scientists mainly write really big numbers or really small numbers without having to write a whole lot of zeros. So whenever they're looking at a number that's huge, that has lots of zeros at the end, or a number that's really small, maybe it has lots of zeros after the decimal point before the actual number, they have a shorthand way to write it so that it doesn't take so long to write. So when you see a number written in scientific notation, it'll be made up of a base number, which looks like this. It always has one place, one actual number that's not zero before the decimal point every single time. Only a number in the ones place and then the decimal. And then it will be multiplied by 10 because, as we know, our place value system is based on the number 10. Each place that you move is 10 times the place before it. And then the 10 will be multiplied, will have an exponent showing you the number of zeros that would go after this number if we were to write it all out. So to take a really big number like 1,260,000, for example, and write it in scientific notation, we take that imaginary decimal point and we're going to move it so that there's just one digit in front of it. Okay, and I'm going to count the places as I move it. So I'm going to count 1, 2, 3, 4, 5, 6. So I've moved it so that it's 1.26. I only have one number in front of my decimal. I always am going to write it times 10 every single time. And then the exponent is a 6 because I had to move that decimal 6 places to get it there. Now, when we're writing really big numbers, we're moving our imaginary decimal point at the end of the number to the left, right? So I'm taking it from here and I'm moving it between the 1 and the 3. And if I count as I go, I'm moving it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. So I've got 1.3 times 10 to the 10th power because I moved it 10 places. Because I moved it to the left, and we're talking about a big number here, my exponent is positive. However, if we're talking about a really small number, notice I have to take my decimal point here in this example and move it in the other direction to get it so that there's one number that's not zero in front of it. I have to move it between the 4 and the 5. 1, 2, 3, 4, 5, 6, 7, 8 places. So now my number is 4.5 times 10. I'm still writing an 8 for my exponent because I moved the decimal 8 places, but to show that this is a small number and that I moved my decimal to the right to get it there, I have to make it a negative 8. So my exponent is negative if I'm moving my number to the right, if we're talking about a really small number. Now, if I'm going the other way and I have a number in scientific notation and I need to move it back to standard form, I'm simply going to follow the directions that exponent gives me. So this exponent says that in order to get to the spot it's in now, that decimal moved 3 places to the right. So if I want to take it back, I need to move it 1, 2, 3 places to the left, and I'm going to fill it in with zeros in the empty places. You should be able to check by seeing if you were to move that decimal 3 places to the right, would you have the same number you started with? If I were to take this decimal and move it 1, 2, 3 places to the right, it would be between the 1 and the 4. So I know that I have that decimal in the right spot, and I know that I have the correct number of zeros filled in those blanks. In this example, I had to move the decimal 4 places to the left to get it where it is now. So I'm going to simply move it 1, 2, 3, 4 places to the right to get it back to where it was. And again, if I check, I should be able to take the imaginary decimal point 1, 2, 3, 4 places. Yep, that makes it correct. So we fill in our empty spaces with zeros and we get 35,600 is our original number. So this is all about moving the decimal to the right or the left and then labeling it correctly so that someone could follow the directions you've given to rewrite the number in the other format. So let's take a look at some examples as they will come up in your progress monitoring. The first example says which of these numbers is expressed properly in scientific notation. So really all we're doing here is looking at the format. And if you remember correctly, there should only be one number in front of a decimal in scientific notation. So if you look at choice A, there's 3 numbers in front of the decimal. Choice C has 2 numbers in front of it. So that means choice B is the only one that is correct scientific notation. And that's really all you need to know for that example. The next example says write this number in scientific notation. So I'm going to take my imaginary decimal point and I'm going to count the places I move it. 1, 2, 3, 4. I'm going to write 1 point, 2, 3, 4, 5. I can't leave any of those numbers off because they're not zeros. And I'm going to always write times 10. And in this case, I moved my decimal 4 places. So I'm going to write the exponent 4. The next example says the radius of a planet is 134,000 kilometers. What is the radius of the planet in scientific notation? So I'm going to take my imaginary decimal point and I'm going to move it 1, 2, 3, 4, 5 places. I'm going to write 1.34. Now this time I can leave off all those zeros. That's kind of the whole point, right? I'm always going to write times 10, and in this case I had to move my decimal 5 places, so it would be 10 to the 5th. The last example says write the number as a decimal in standard form. So in this case, I had to move my decimal 5 places, but if you see that exponent is negative, which means I'm writing a really little number here. So I'm going to be moving my decimal 5 places to the left to get back to where it was. 1, 2, 3, 4, 5. And when I fill in all my blanks with zeros, I'm going to have 0.0000019. And if I want to check, I can imagine moving my decimal 5 places over and make sure it lands between the 1 and the 9 like it's supposed to. 1, 2, 3, 4, 5. Yep, that means we did it correctly. So now you're going to go ahead and do the You Try It problems. Feel free to go back and rewatch parts of this video to look at examples as you need to. And when you're finished with the You Try It problems, if you still need more practice, there are links at the end to additional practice and games. Happy practicing!